The AI system did not arrive because the shipyards were succeeding. As of May 2026, the U.S. Navy is delivering approximately 1.3 Virginia-class submarines per year. The requirement is 2. That gap between 1.3 and 2 is not a rounding error. It is the number that the Navy's entire 2026 shipbuilding plan was built around. And it is the number that an artificial intelligence system called ShipOS was deployed in December 2025 specifically to fix. The Navy called it a modernization initiative. What it actually is a confession. General Dynamics Electric Boat and Huntington Ingalls Industries, the only 2 shipyards in the United States capable of building nuclear submarines, are both already operating at maximum capacity. The workforce shortages are documented. The supply chain is under sustained pressure. 3 decades of institutional knowledge have not closed the gap, and now the Navy is deploying artificial intelligence to do what those 3 decades could not. This is Navy Unseen, where we do the math that defense headlines skip. Hit subscribe if that matters to you. In May 2026, Admiral Daryl Caudill pushed the 2-per-year recovery date to 2032, 4 years beyond the target his predecessor set. Today we are going to look at what ShipOS actually does inside a nuclear production line and why this is not a story about technology. Start with what a submarine production line actually looks like before an AI system touches it. General Dynamics Electric Boat in Groton, Connecticut, and Huntington Ingalls Newport News Shipbuilding in Virginia remain the only 2 nuclear-capable submarine builders in the United States. While hundreds of suppliers across the country struggle with labor shortages, infrastructure limitations, and production bottlenecks, the Virginia-class is not assembled in one place. It arrives at the shipyard in modular sections, whole cylinders, pressure vessel segments, reactor compartments manufactured at facilities spread across more than a dozen states, shipped by road and rail and barge to Groton and Newport News, where workers fit them together with tolerances measured in thousandths of an inch. A nuclear submarine is not manufactured, it is integrated. And integration, at that level of precision, across that geographic spread, with that many independent suppliers feeding into 2 final assembly points simultaneously, generates a volume of scheduling data that no human team can fully track in real time. That was the problem ShipOS was built to solve. Not the engineering, not the design, the coordination. At General Dynamics Electric Boat, submarine schedule planning was reduced from 160 manual hours to under 10 minutes. Portsmouth Naval Shipyard cut material review times from weeks to under 1 hour. Those numbers deserve to sit for a moment. A scheduling process that consumed 4 full work weeks of a trained analyst's time now runs in 10 minutes. A material review that could delay a production decision for weeks now resolves in less than an hour. The bottleneck was not steel. It was not welders. It was not reactor components. It was information, the lag between what was happening on the production floor and what the people making decisions knew about it. ShipOS is designed to consolidate data from supply chains, production lines, engineering systems, and maintenance workflows into a single interface. Instead of shipyards relying on scattered databases and manual processes, the platform automates forecasting, material tracking, scheduling, and parts availability across the entire production system simultaneously. When a supplier in Minneapolis falls 2 weeks behind on a component delivery, ShipOS flags the downstream consequence for the hull section waiting on that component in Groton before the delay becomes a stoppage. When a welder completes a pressure hull section 3 days early, the system identifies the next available task without a scheduler manually rebuilding the Gantt chart from scratch. This is not artificial intelligence replacing engineers. It is artificial intelligence replacing the gap between engineers, the dead time between one team finishing and the next team knowing it is their turn. The gap matters more in 2026 than it did in any previous year, because the production target the Navy is chasing is not a goal, it is a floor. The FY 2027 through FY 2031 plan invests $124.9 billion across the 5-year defense program for submarine construction alone. That number reflects not just Virginia-class procurement, but the simultaneous Columbia-class build, the replacement for the Ohio-class ballistic missile submarines that carry the sea-based leg of the United States nuclear triad. The Navy identifies undersea warfare as its top shipbuilding priority, seeking to achieve production rates of 1 Columbia-class and 2 Virginia-class submarines annually by fiscal year 2031. Both programs running simultaneously through the same 2 shipyards, drawing on the same supplier base, competing for the same trained workforce. Electric Boat expects to hire approximately 8,000 workers this year. 8,000 in a single calendar year. In a specialized trade that requires years of training before a worker can touch a nuclear pressure hull unsupervised, the workforce problem is not a hiring problem in the conventional sense. You cannot solve it by posting more job listings. You solve it by retaining every person currently on the floor, reducing the inefficiencies that burn out experienced workers, and compressing the training pipeline by giving new hires better tools and clearer workflows from their first week. ShipOS is partly a scheduling system. It is also partly an answer to the question of how you scale a workforce that took decades to build. None of this exists in isolation from the strategic pressure driving it. The Virginia-class increasingly absorbed operational roles previously divided among Los Angeles-class, Ohio-class, and specialized ISR submarines while supporting distributed sensing, seabed warfare, covert strike, and long-duration ISR missions. The submarine the Navy is struggling to build fast enough is simultaneously being asked to do more than any previous submarine in the fleet's history. Anti-submarine warfare, land attack with Tomahawk missiles, covert intelligence collection, special operations support, seabed warfare. The Virginia Payload Module, introduced in Block V, added a 70-foot hull extension and 2 8-additional missile tubes, expanding the boat's strike capacity while adding weight, complexity, and production time to an already stressed build schedule. Block 6 represents the latest iteration, featuring enhancements in stealth, efficiency, sonar arrays, propulsors, and seabed warfare tools. Each block adds capability. Each block adds production complexity. The learning curve that the 2 shipyards climbed building Block I hulls in the early 2000s does not transfer cleanly to a Block 6 hull that is physically larger, more capable, and more demanding to integrate than anything Electric Boat has built before. The Chinese submarine fleet is not waiting for that learning curve to flatten. The People's Liberation Army Navy currently operates more than 60 submarines, including a growing number of Type 093 nuclear attack submarines and Type 094 ballistic missile submarines. The gap between Chinese submarine production capacity and American submarine production capacity has been narrowing for years, not because China builds better submarines, but because China builds more of them, faster, at shipyards that are not simultaneously constrained by the workforce shortages and supply chain pressures that are currently forcing the United States Navy to deploy artificial intelligence just to maintain a build rate of 1.3 hulls per year. That asymmetry is what makes the 2032 recovery date feel less like a schedule and more like a risk. The pilot data from Electric Boat's Groton yard is real. The 160 hours to 10 minutes reduction is real. The Navy plans to expand ShipOS across additional shipbuilders and suppliers by the end of 2026, integrating automation, predictive maintenance tools, digital engineering, and AI-supported logistics management throughout the maritime industrial base. The system is not a prototype. The Navy awarded Palantir a contract worth roughly $448 million to support ShipOS, marking one of the largest defense technology collaborations Palantir has secured to date. But a $448 million AI contract does not build a submarine. It builds the coordination layer around the people who build the submarine. And the people, the welders, the nuclear systems technicians, the quality assurance inspectors who sign their name to a pressure hull that will operate at crush depth with 135 sailors inside it. Those people take years to develop, years to retain, and cannot be replaced by a scheduling algorithm no matter how fast it runs. ShipOS can tell a shipyard what to build next, when to build it, which components are arriving late, and where the bottleneck is forming 3 weeks before it becomes a production stoppage. It cannot weld the joint. It cannot inspect the weld. It cannot certify that the reactor compartment is ready to receive its core. The Navy knows this. The $448 million contract is not a solution. It is a force multiplier applied to a workforce that is already stretched to its limit, trying to close a gap that has been widening since 2018. By the time the first ShipOS optimized Virginia-class hull delivers on an accelerated schedule, if the system performs as the pilot data suggests it can, the watch teams aboard that submarine will have no awareness of the scheduling algorithms that coordinated their boat's construction. They will know the reactor, the weapon systems, the sonar suite, the communications equipment. They will know the depth the hull can reach and the targets it can strike from there. The 2032 recovery timeline represents not just a production goal, but a national security imperative, requiring unprecedented coordination between government, industry, and educational institutions. The AI system arrived because the coordination was failing. Whether it arrived in time is a question the build rate data will answer, one hull at a time between now and 2032. The shipyard floor in Groton does not stop between ships. The overhead cranes move, the hull sections arrive. The workers who have been on the floor since 0500 hand their tools to the crew coming on at 1300, and the production clock keeps running, regardless of what the scheduling software says the timeline should be. The gap between 1.3 and 2 does not close on a dashboard, it closes on the floor.